Good day and welcome to another physics lesson. This lesson is about impulse and linear momentum. Today we will define and state the formula for impulse of a force. We will calculate impulse. We will define and state the formula for momentum. We will see how momentum and impulse relate with each other, and we will state the principle of conservation of linear momentum, just as we explain different types of collisions. And of course, we look at a few problems there and how they can be solved. So, let's get started. First, impulse of a force. What exactly do we mean by impulse? Impulse is a quantity that is associated with collision. When collision occurs, that means when two bodies, two objects or more collide with each other, what actually happens then is that they exert a force, a large force on each other, but for a very short time. You can imagine all the incidences of car crashes you may have seen or watched in movies. You will see that a large force is exerted by the colliding bodies, the colliding cars, but that force is exerted over a short period of time. So each of the bodies receives a blow. We call it a blow, but in this case, in physics, that blow is actually what is referred to as impulse. And how then do we find impulse? Impulse is the product of the force that acts on the body and the time during which it acts. So impulse is force times time. Impulse is a vector quantity. That means it is directional. So it has a direction that is the same as the force that acts on that object. So the direction of impulse is the direction of the force. If you all remember our previous lessons, we already established that force is also a vector quantity. So here, the direction of the force is what also gives us the direction of the impulse. And looking at the formula, it is easy for us to see what the units for impulse will be. Units for force is Newton, unit for time is seconds. So that's Newton times seconds. Unit for impulse, therefore, is Newton seconds. On the other hand, let's look at momentum. Momentum, linear momentum in this case, because there's also another kind of momentum called angular momentum. But in this case, we are looking at linear momentum. So linear momentum is a property of objects in motion. Objects in motion. You remember that we already know that every object has a mass, because every object is essentially matter, and matter is anything that has mass and occupies space. So every object, whether in motion or at rest, has a mass. But only moving objects have a velocity. If an object is not moving, it does not have a velocity. Therefore, momentum depends on motion of an object. If the velocity is zero, then momentum does not exist. Momentum is zero in that instance. But if the object is in motion, then it has a velocity. And if it has a velocity, then it has a momentum, because already it has a mass. Whether moving or not, every object has a mass. So momentum is mass times velocity. So I say again, for an object to have linear momentum, it must have two things. One, it must have a mass, which we can take for granted that it does. And then two, it must have a velocity. If these two quantities are not there, then the object does not have a momentum. The units for momentum is also gotten from the formula. The formula is mass times velocity. Therefore, unit is kilogram meter per seconds. Kilogram meter per seconds. Let's solve some simple examples with regards to what we have looked at so far. First, impulse. We are asked to calculate the impulse experienced by a ball that was kicked with a force of 30 newtons And the time for which the force acts on the object is 0.5 seconds. Like I said earlier, impulse is force times time. So you just multiply 30 newtons by 0.5 and you get 15 newton seconds. The second example is about a car that has a mass of 1,500 kilograms, and you are asked to find its momentum given that its velocity of motion is 30 meters per second. That also is straightforward. Momentum is mass times velocity. That gives us 45,000 kilogram meters per second. Now let's see how impulse and linear momentum relate with each other. And this is gotten from second law of motion. You will remember from our second law of motion, it states that the rate of change of momentum of an object is directly proportional to the force applied. So rate of change, as I have already said it in previous lessons, whenever you hear rate of change, it means that there is a denominator there that is time. Rate of change always means that time is a denominator. So we have rate of change of momentum. That means change of momentum divided by time is equal to the force. And when you hear change of something, change means you are subtracting two things from each other. When you're finding a change in length, for instance, that means you're subtracting two lengths from each other. You are looking for a change in mass. That means you are subtracting two masses from each other. So when we have change in momentum, we are subtracting two momenta from each other. The final momentum being mv, because v stands for final velocity, if we recall, and u stands for initial velocity. So m times v, that's the final momentum. M times u, that's the initial momentum. Now, mv minus mu is the change in momentum. Now, mv minus mu over t is the rate of change of momentum. Now, F is equals to rate of change of momentum. That means F equals mv minus mu over t. In this case, if I take t to the other side to go and join F, that means I do some form of cross multiplication there, you will find that ft equals mv minus mu. Now in this lesson, we have already said that ft is the formula for impulse, and mv minus mu is change in momentum. Like I said, when you're subtracting two things from each other, that means you're finding a change in that thing. So we are looking for a change in momentum. So mv minus mu, which is a change in momentum, is equal to ft, which is an impulse. That means that impulse essentially is also equal to change in momentum. Therefore, if you're looking for impulse, but the data you have can only give you change in momentum, just go ahead and find your change in momentum, and whatever answer you get, you just need to put the accompanying unit for whatever it is that you're looking for, and you will have got the answer for that question. Let's see a solved example in this regard as well. We have a ball that experiences a force of 100 newtons and creates a change in momentum of 120 kilogram meters per second. You are now asked for how long did the force make contact with the ball. Here, we are already given the change in momentum. We already have mv minus mu, which is the change in momentum, and that's 120 kilogram meters per second. And as we said, change in momentum is equal to impulse as well. So an impulse is force times time. The question already gave us force. So 100 times t equals 120. We are looking for t. If we divide 120 by 100 to get our t, we will get 1.2 seconds. The second question here is about a ball of mass 5 kilograms moving at a velocity of 5 meters per second. This ball is hit by a force of 10 newtons for a duration of 0.5 seconds. Find its new velocity of motion. Here, we are looking for v. Find its new velocity. We had a former velocity, an initial velocity u, which was 5 meters per second. So if we use the formula that we use, Ft impulse equals change in momentum, mv minus mu, we'll find that our v here will be equal to 21 meters per second, because already the question gave us the force and it gave us the time. So that means there we already have impulse. Impulse is force times time. So we already have impulse. Now impulse is equal to change in momentum. That means impulse is equal to m into v minus u. We have m, 5 kilogram, and we have u, 5 meters per second. Then we can find v, and v is 21 meters per second. Now let's look at conservation of linear momentum. Linear momentum. When we talk of conservation in physics, essentially we are talking of a quantity that its total value is preserved in a system. A quantity that has a constant value in a system. That's what conservation always deals with. Whenever we talk of energy conservation also, we are essentially trying to talk about keeping the quantity of energy in a system constant or the same. So conservation of linear momentum is a quantity or a principle that talks about how momentum is conserved in a system. It's a principle that works with collisions when bodies collide. So if two or more bodies collide in a closed system, then the total momentum after the collision must be equal to the total momentum before collision. Now, what are we saying here? Are we saying that the momentum of the individual bodies must be the same? No, that's not what we are saying. What we are saying, what this principle is about, is that before two bodies collide, each one had its own momentum. At least before two bodies can collide, one of them must have been in motion. At least one must have been in motion before collision. It is possible for a moving car to hit a stationary car. That's possible. But it is not possible for two stationary cars to hit themselves. That's not possible. So for a collision to occur, it's either the two bodies were in motion or at least one of them was in motion. So when a collision then occurs, if we add up the momentum of the two bodies before the collision, and then we now do the same, add up the momentum of the two bodies after the collision, the answer we will get in the same scenarios must be the same. So if we have body A and body B, body A had its own momentum, body B had its own momentum. Now body A and B now collide. If we find the total momentum before they collided and we find the total momentum after they collided, we must get the same answer. That is what the principle of conservation of linear momentum talks about. Now, what do you mean by closed system? Closed system just means a system that no external forces act. So a system that is conserved, a system where there is no energy loss, so to speak. There's no energy loss. That's a closed system. Though it is more of an ideal system and less of a realistic system. The only particles that come close to having closed system collisions are probably gases that are in an enclosed container and that have been kept in constant motion. For two bodies to collide, as I said, at least one of the bodies must have been in motion. So before the collision, the two bodies had momentum individually. After the collision, they also had momentum individually. When we add up their momenta before and after, we should get the same thing. That is what the principle of conservation of linear momentum talks about. Therefore, talking about this principle, we have an equation that it gives us. That's mass of body A times initial velocity of body A plus mass of body B times initial velocity of body B equals mass of body A times final velocity of body A plus mass of body B times final velocity of body B. Remember that momentum is given by mass times velocity. That's why we have masses times velocities here. So A and B are the two bodies colliding. So body A before collision had an initial velocity. Body B also had an initial velocity. Now after collision, body A would have a final velocity and body B would have a final velocity. So if we add up the momenta before and after, they should be equal to each other. Let's look at an example. Two cars A and B of masses 1,200 kg and 1,000 kg are traveling in the same direction along a road, and they have velocities 20 meters per second and 9 meters per second respectively. Then they collide. So we are asked to find the velocity of car A after the collision. We are given the velocity of car B as 12 meters per second. Slotting all the values we have into the equation we had on the previous slide, we'll see that mass of the body A is 1,200 kg. It's already given. Mass of body B, 1,000 kg, also given. So just slot them in. We had initial velocities of bodies A and B. We also slot those ones into UA and UB. After the collision, body B had a velocity of 12 meters per second. But we do not have the velocity of body A. That's what we are looking for. So just slot out all the things that we have into the equation and then solve for velocity of body A. If you do that correctly, you will get a velocity of body A as 17.5 meters per second. Now, that is the solution to the example. You can also try it and see if you get the same answer. Now, we should take note also that momentum is a vector quantity. Therefore, direction is important. As I said earlier, for two objects to collide, at least one of them must have been in motion. So, in a case where we have the objects, maybe the two of them in motion, the direction in which they were moving before the collision as well as after the collision have an impact on our calculation. So let's look at the types of collision that we have. We have two main types of collision. We have the elastic collision and inelastic collision. When you think of elastic, just think of something that stretches and returns to its shape. That's elastic. Stretches and returns. There's a topic in physics, elastic properties of solids. Now, in an elastic collision, the objects that collide, they don't collide and stick together. Rather, they bounce off. So when two objects collide and then they bounce off each other, they are it's like you stretching a rubber and it returning to its original shape, in a manner of speaking. So when two objects collide and then they don't stick together, they bounce off. They bounce off each other. That collision is an elastic collision. On the other hand, if two objects collide and then they stick together after collision, they stick together and move off as a unit, as one, that collision is inelastic. A good example is when you have a sports car that runs under a truck, a big truck. You have a sports car speeding on the express, and then maybe didn't know that there was a truck going ahead, loses control and runs under the truck. You find that it gets stuck there and the truck probably drags it along. So they move off as a unit. So in that situation, we have an inelastic collision. Now, also we should note that if the two bodies that collide were moving in opposite directions before they collided, if they were moving in opposite directions, that means one was going towards the left, the other was going towards the right, we can envisage this as a head-on collision. Two cars moving in opposite directions that have a head-on collision. If this happens, then because of that opposite direction of motion of both bodies, the plus that we have on the initial velocity side of the equation will become minus, because we have two things opposing each other in motion. So if one is going towards the positive side, the other will go towards the negative side. So the body A, assuming that was going to the positive side, then body B will go towards the negative side. That is why we have the minus there for before the collision. Now, in an elastic collision also, elastic meaning that after the collision, they bounce off each other. They didn't stick together. Now, if the two bodies bounce off or move off in opposite directions also, then for the part of the equation that has to do with final velocity side, that plus sign will become a minus sign also, because of the opposite direction. In physics, whenever we talk of opposite, if one carries a positive sign, the other will carry a negative sign. So that is why we have a minus in front of our mass of body B and velocity of body B. Body A and velocity, mass of body A and velocity of body A will have carried a plus. So you know in mass, when a quantity has a positive sign, we don't usually put a positive sign there. So put this into consideration. Now, these two scenarios I have painted can also work together. So it may even be that you had bodies that were in opposite direction of motion before collision, and then after collision they again went off in opposite direction. That means that in this case, both sides of the equation will carry the negative sign. I repeat, if before the collision the bodies were moving in opposite direction, and then they collided, and then after the collision they again move in opposite directions, that means that both sides of the equation will carry the negative sign. Again, let's look at some examples. We have two cars of masses 500 kilogram and 700 kilogram moving towards each other. Moving towards each other essentially means that they are moving in opposite directions. Two cars move towards each other when they are moving in opposite directions. Then they collide in an inelastic collision. Inelastic means that after they collided, they got stuck with each other. They got stuck. They became one unit after the collision. Now, if the velocities of the cars before collision were 20 meters per second and 10 meters per second respectively, find the velocities with which they both move off after the collision. Now, take note that the question said they were moving towards each other. That means that before they collided, they were moving in opposite directions. So on our initial velocity side of the equation, which is the left-hand side, that plus that should have been there will become minus. Now, on the right-hand side, the question said that it was an inelastic collision, meaning that they got stuck with each other. And when two objects get stuck with each other, they cannot move with different velocities. They have no choice. They have to move with the same velocity. So that's why I just collected the like term v from the equation, because since v will be the same, it can be a like term and brought outside the bracket. So in this case now, we can now find v, which the question asks us to find. I will advise that you pause this video at this point and try to solve for v before you go on to the next slide to see what the solution is. Now you see the solution to that question. The answer is 2.5 meters per second, given that you have done everything right. So this is the end of our lesson on linear momentum and impulse. And we have assignments as usual. I like that you take some questions down for you to practice, for you to work on your knowledge better. So take down these questions and attempt them as your homework. If you have any questions you would like to ask, any gray areas, feel free to drop a comment under this video on this page. And I don't forget also to subscribe to the page And do not forget also to check on the other lessons that we have on this page to further enhance your knowledge of different physics topics. Thank you for today's lesson, and I hope you enjoy it.